Hey guys, welcome to DrillDevOps. DrillDevOps is an online training platform where we are gonna teach you about DevOps. We are gonna train you on DevOps, and we talk about public cloud, AWS, and we are gonna talk about provisioning of infrastructure on AWS using infrastructure as a code tools. So let's start. Let's see what we are gonna offer you in the course period of time. Okay, so this is about our course scope where we are going to cover you introduction of DevOps, how it has evolved over a period of time, and then we are going to teach you about Linux where we concentrate more on daily based commands, and we are going to talk about network file systems, system information, process management, text management, and we are going to teach a lot of things here. And on the scripting part, we are going to cover you bash and python. So in this we will we'll cover about the real-time scripting concepts where we can see the health checks of a service. We are going to do the disaster recovery process, how it can be done for tools, different tools. And on python side we are going to use the apis and do some operations related to the api based on the outputs that we are going to get. So we will cover all these topics when we get the that particular topic. Coming to GitHub, here we this is a source code management tool. We will talk about GitHub and Maven, SonarQube, Nexus, Jenkins. All these tools are continuous integration and continuous delivery process tools where we will show you each tool, the architecture, and then the regular commands that we use, and we are going to show you the real-time projects with taking an example of application and then building an application, checking the code quality, and publishing the artifact. So these things will be integrated with Jenkins, and we are going to show you the pipeline as well. Coming to Tomcat, Tomcat is again a web application tool where you can host your application there. And Docker is a container management tool where you can give where you can run your containers by using an templates called images. We can build a base image, we can build application images, and based on that we can create an containers out of it. So we are going to teach you about the architecture, the networking part, and then containerizing your application. Coming to Kubernetes, again Kubernetes is an container orchestration tool. When you have a large scale applications and you want to manage that, you go for orchestration tool, and Kubernetes is one we are covering in this course. Coming to AWS infra services, we have a lot of infra services that we are going to cover you. We are going to discuss in the later part of this session. So we are going to cover infrastructure as a core tool called Terraform. We have different tools, but in this course we are pointing Terraform as it has been widely used, and we're going to discuss why this has been widely used and what are the advantages of Terraform here. Ansible is a configuration management tool. Once you provision your infrastructure, we're gonna do some dependency managements, application deployments, or task related to the application even before deploying, like prerequisites. We're gonna do reusable tasks using Ansible. And then we are going to cover observability stack, which is for infra and application monitoring. We have a lot of tools in the market. The scope of our course is on Prometheus and Grafana, which has been widely used by many organizations. We are going to cover that. And then ELK stack for log monitoring, where Elasticsearch, Logstash, and Kibana are the components that we use in this stack, and we want to show how log data has been taken, processed, and showed in the graphical manner. Let's jump into the course. So on the introduction part, we will talk about SDLC lifecycle, the basic waterfall model, which is which is first waterfall model and legacy one, and advantages and disadvantages of that. And we are going to shift to the agile methodologies, which is the latest model of current projects and companies that have been using. We have safe agile, and we're going to discuss what those are. Post that, we are going to talk about history and evolution of DevOps, and how it has been evolved over a period of time, and what is the current status of DevOps and how it is going to change in future. So next topic is the goals of DevOps, and what kind of things that we are going to achieve when we implement DevOps on a project, and what are the key principles that we should follow to achieve our goals in the DevOps architecture or a methodology when you implement on a project. Suppose that we will cover comprehensive overview of DevOps, which covers right from setting up the branching strategies till the deployment and monitoring phase, where we will cover all the process related and the technical part that we are going to cover in this course. We're gonna see how each tool is behaving, and how it has been processing the step by step of each tool. So that is what we are going to discuss about in comprehensive overview of DevOps. Coming to this slide concentrates more on agile methodology, which focuses when you implement what happens to DevOps when you implement Scrum, and what happens, what scenarios we follow with the Scrum, and when do we pick Kanban during our DevOps implementation, or to the matter of fact, when we want to implement Scrum and when we want to implement Kanban during a uh, when any project is at implementation stage. And we're gonna take Jira as an example, and we'll show you how to what sort of difference is there between the Scrum and Kanban dashboards, the sprint plannings, the project requirements gathering. We're gonna talk more about this on the agile methodology part. Coming to next topic, we will talk about DevOps. So DevOps in this process, what happens during what happens to a project when you implement DevOps. Basically, we talk about the software development and the IT operations, and reducing the gap between the development and operation side, and enhancing the software delivery process by emphasizing the customer collaboration and communication between the teams, and we will collaborate with development and operation and multiple teams involved in the entire project, and then we're gonna track each and everything from a project point of view using one project management tools like Jira, and then we take the automation in this process where any manual tasks that has involved, we will automate it, and make it simpler way for any developers or any QA teams that have been involved. And we're gonna take the feedback of the entire process once it is implemented, and based on that we are gonna provide the DevOps model to the next level, which is available in the market by using various tools, technologies, and automations that brings up and constitute to the project in smoother delivery of a product. That is what we are going to discuss in this particular DevOps overview. Coming to operating system, we have many operating systems or OS that have been involved in the entire software industry. We can talk about Windows, we can talk about Unix system, we can talk about Mac OS, but market leader for DevOps projects or any company that have been using any sort of OSs is predominantly Unix based systems. Under Unix we have many distros. You have Linux, you have CentOS, we have Fedora and stuff. We are gonna cover Red Hat Linux here, for all the architecture part, kernel, basic commands. We are gonna cover lot of things here, right from the storage till the utility commands like cron tab, symbolic links, and archive commands like that. We're gonna talk each and everything that is displayed in this template. Coming to next part, so in this, like I said in the previous slide, we are going to cover GitHub. And what is GitHub? GitHub is a source code management tool where developers, once they write the code, they need one centralized repository where they can push their code, and that is the hub to track all the changes, on all the bugs that have been created, everything that comes into one place, and you can track all the changes, conflicts, and you can see the merging updates. We can whole lot of things by using source code management tools. Here we are covering GitHub, and we have other tools such as GitLab, Bitbucket, TFS, SVN, that helps to store the code. Next thing is build tool. Build tool. So basically, when you write a code, let's suppose we have written some Java code, and it's a plain Java code. You cannot give the code to any end user and ask them to run it and see the output. You cannot do that. We have to share the executable files. Like let's suppose if you are using Windows, if you want to install VLC player, you cannot take the raw code of VLC player and run it and get the application out of it. You need to have an executable file. So to get that executable file, we need a tool called build tool, which could be Maven, which could be MS Build for .NET applications. It could be Ant or Gradle. To the matter of fact, you can use any of these build tool. In our course, we are concentrating more on Java based applications, and we're gonna take Maven as a build tool, and Maven um, um, revolves around the build life cycle, and we have project object model which is called as POM. We'll write all the dependencies, plugins, properties, distribution management inside that, and we're gonna build a project and see what it gives you as an output. So this is our build tool, and we will get executable files, which could be jar, var, or EAR files out of it, and that can be used directly to spin up an application or deploy it somewhere in the servers. So that is about build tool, and we're going to cover Maven in this project, right from the build life cycle till the completion of build stage and publishing the artifact to some other third party tools. So static code analysis, it's again a tool that actually covers that actually tests the code, the quality of the code that developers has written based on the rules, and we want to test the code coverage, what sort of coverage they have done, what kind of percentage of the code that they have written, and we're gonna see the entire vulnerabilities, bugs they have included in the code. So this is one tool that actually tests all these things based on the plugins that we give, like Java code coverage or Kobertura. Based on that, it is going to cover unit test coverage, code analysis. It performs the bugs. It lists out the vulnerabilities, duplications based on the rules that we have set in the SonarQube dashboard. So we want to talk about all the installation process, all the settings, configurations that we do on top of SonarQube once it is up, and how to integrate with the Maven, so that we're gonna create a entire ecosystem between build and code analysis phase. And then we have other tools in the market like Veracode and Covert. We do have some other tools, but we cover SonarQube in this particular course. So artifact repository, what is the need of artifact when you have already code running, which is residing on the GitHub? So the need for artifact is like, so if you are running a small application, it builds in few minutes, or sometimes it is in seconds. But when you have a large scale applications, or to the matter of it, in real time, any application cannot be built in minutes. Sometimes it takes hours. Sometimes it takes 30 minutes, or more, like that. We cannot, let's suppose you have one application that is running in production and somehow it went down, and you want to roll it back to the previous version. To roll back to the previous version, you should have ready-made artifact available to deploy on the servers. So if you don't have any artifact repository tools that stores all the previous version of artifacts, then you have to build the previous code, get the artifact, and publish it to the Nexus and deploy it to the servers. You cannot do that in the over a small period of time, because it gets your application down and you see the downtime of your application and customers gets impact and your brand value gets reduced. So it is going to impact a lot. So to mitigate that, we have artifact repository tools where you can store the release versions and snapshot versions of your artifact. Here artifact in the sense it's a package that I have discussed, like jar file, war file, or ER file. We can store all these packages into the artifact repository, which is called Nexus. Here we are covering Sonatype Nexus, where I'm going to show you the installation process, the types of repositories it supports, and the integration in the build lifecycle, how we are going to integrate these. So we will store the artifact in Nexus, and we will use it for dependency management in our current process and see how it has been useful for both dependency as well as artifact storage. So we will integrate with the build process and publish the artifact over a single click, or using the build commands. So that is what we are going to cover here. We have other artifact repository tools like Artifactory, JFrog, and S3 bucket, AWS S3 bucket. Also, you can use it as artifact to store your Java or ER or executable files. So coming to CI/CD tools, you can consider CI/CD tool as a hub or a umbrella to integrate all the other tools that comes into the DevOps world. If you consider, here we are taking Jenkins as an example. We cover Jenkins in this, and we have all the tools that I've discussed earlier. We can integrate all those tools with Jenkins, and the tools that I'm going to discuss after this slide, those tools also can be integrated with Jenkins. Basically, Jenkins is a heart where you can install a plugin and start using it, and it performs the task that you have defined in the jobs. So that is how it works. So basically it will help you to build your code, bring up the infrastructure, and make the changes to the deployments, and it is going to deploy your infrastructure. So that is what this tool is going to do. And we have other tools like Circle CA, Argo CD, GitLab, Bamboo, TeamCity, and we have lot many tools in the open source. Coming to containerization tool, so we have container runtime, where you have Docker, we have Podman, we have Containerd. All these tools provide you the lightweight OS, which is called images, and you can create a you can create a OS out of the images, which is called containers, and based on that you can package your application dependencies and application into one single unit and use it in the different environments. So you can achieve the consistency in all the environments, and it will be a lightweight, where you can easily transport it between the environments. So containers will be mostly useful for microservice based architectures, or applications which is having less features, or mid-size or small scale applications it can be used. So that is what a container helps you to do when you start with Docker. We have a lot of things to discuss about. We will talk about Docker architecture. We wanna see the Docker basic commands, the installation process, and we wanna containerize one Java application and see how we are going to build a base image, and from base image how we are going to create an application image, and how we are going to store it and deploy it on the EKS clusters or Kubernetes clusters. That is what our course scope for containers we are going to cover, and then we have Podman and Containerd as an open source other counterparts of Docker. Okay, in this slide, we can think of why we need container orchestration when we have container runtime, which is called Docker. So what is the need of orchestration? So when you are having a small application which is serving less loads, and when you are working on small scale projects, you can think of using Docker. But when you have a large scale applications and you are using a microservice based architecture and you need to deploy, you need to manage a lot of uh, deployments. You need to have manage the lot of networking part, the exposing your service to the outside world. We have to manage a lot of things in the container world when you talk about microservice based architecture. So and Docker is not preferable when you have large scale or when you are managing huge number of applications at scale. So we use one medium or a tool which is going to suffice or are easy to manage these containers when you are using a large scale. So here we have Docker Swarm, which is coming from Docker, and we have Kubernetes, we have OpenShift and Rancher, which serves our purpose to manage our applications. Here we are choosing Kubernetes because of its wider advantages and the usage of many big organizations and the expectations of any DevOps profile to have a Kubernetes as a go-to tool. So in this, we are gonna set up the entire. We are gonna teach the Kubernetes architecture. We are gonna train you on the setting up the infrastructure and the deploying the Kubernetes on top of the infrastructure and setting up the cluster, not deploying, setting up the cluster on Kubernetes machines, EC2 machines, be it EC2 machines or EKS, however is feasible, and we're gonna cover the entire deployment flow and see the terminologies, the objects, resources that is constituting to complete the flow of Kubernetes. So we are gonna talk more and stress a lot of things here, but we are not covering certification topic, complete certification topics. But we gonna see the terminologies, the usage, and based on the containerized applications, we want to see how it is going to be deployed by using Argo CD as a continuous deployment tool in this Kubernetes. That is what we want to cover here. Coming to the next slide. Okay, this is about public cloud. So we have multiple clouds like public, private, mixed clouds and all, where we call it as hybrid clouds. So here we are going to cover Amazon Web Services, which is a public cloud. So we're gonna talk Amazon public cloud supports like 300 plus services inside it. We're gonna talk. We are not gonna talk all these services. We want to concentrate what is going to constitute for DevOps methodology or DevOps culture. What comes into our scope. We wanna talk about that and see how each service is behaving and how it is helpful for our DevOps ecosystem. So in this, we use AWS as a infrastructure provider, where we create the infrastructure, provision infrastructure using Terraform, and try to deploy applications on top of it. We're gonna set up the entire environments, and we're gonna see how to create the infrastructure pipelines on AWS uh, and see how network is happening, how network is behaving, and see VPCs, load balancers. We're gonna talk about CloudWatch for monitoring, Route 53 for routing your applications to your URLs and the target groups that we have. And we're gonna talk about auto scaling groups, ECR for storing our images, EKS for AWS version of Kubernetes clusters, web application firewalls. We want to talk about the security part, like NAT and security groups, IAM for managing the permissions related to the project, how each project behaves, and how to connect to the AWS. We want to talk more about AWS infrastructure as well in this course, and see how we can provision infrastructure and deploy our applications. That is the scope of AWS in this particular course. We have other public clouds like GCP, Microsoft Azure, Alibaba. We have many things. Coming to infrastructure as a code tool, we take Terraform in our project in the course period, and then we're gonna create the provision the infrastructure on AWS using Terraform. Why we need to use Terraform? Why not AWS CloudFormation or Pulumi that is been available? The reason why we are going with Terraform is when, let's suppose you have currently you are working or are provisioning infrastructure on AWS, and at certain point of time you choose to switch your cloud provider from AWS to GCP, or to the matter of fact you can move to any of these open source public clouds if you want, or if you want to choose private clouds you can always choose. When you want to move into such environments, you have to rebuild your code. If you are writing in AWS CloudFormation, you are bounded to one particular public cloud, and you have created a lot of dependency on that cloud, and if you want to move out of it, it takes a lot of time for you to move. But if you use Terraform, it is very easy and reliable to migrate your applications or infrastructure from one cloud to another. Terraform supports 600 plus providers, and it has matured over a period of time, and then it is a market leader for infrastructure as a code service provisioning tools. And Pulumi is again one good tool that we can think of, but Pulumi is not matured enough, and it is at its mid stages, and it supports Python. It supports a lot of languages, but Terraform is market leader, and that is where most of the organizations use. And to write Terraform code, we use JSON language, which is Java subject object notation, and we're gonna show you the entire process of how Terraform architecture behaves, how the plugins behave, and how to write the directory structure of Terraform, how to write a Terraform at reusable models. Like if you want to launch your infrastructure for multiple environments, we can just change the environment variables, or the variables that we want to pass, and create multiple infrastructures by using reusable modules combined together, and then create the infrastructure. That is how we gonna show you at that level. We gonna create a infrastructure pipelines, and based on the on these pipelines we want to create multiple infrastructure like dev, staging, and production. Coming to configuration management, is again it's a tool where it helps you to achieve the repetitive tasks, instead of you logging into one machine and trying to do the same work on multiple machines. It helps you to manage the repetitive tasks, scaling the infrastructure, and you can use it for deploying applications, and set up the provisioned infrastructure for your deployment. So basically, in a simpler terms, when you have one or two servers, you can easily log in and do install Java, or basic things that you need for your application before deploying. If it is like 100 servers or 1000 servers, or your infrastructure is a dynamic infrastructure which is supporting large scale applications, which is scaling up and scaling down whenever you have scheduled it, or based on the time frames, or scheduled scaling or if it is like scaling based on the loads. If you have done such kind of work, then you cannot manage your application during the fly. So that is where Ansible comes into picture, where it is very helpful when you have a dynamic infrastructure. Dynamic infrastructure comes in any cloud providers. So we, for any dynamic infrastructure, Ansible is a go-to tool for configuration management, as it has been evolved over a period of time, and it's market leader for configuration management. So with Ansible you can also create infrastructure, but the primary use case of Ansible is for configuration management. So this is again I'm gonna take one example and then compare it with the chef, and tell you what's the difference: the architecture, the installation process, static inventory, dynamic inventory. I'm going to take static inventory as example and deploy one application, and dynamic inventory as one example and deploy application. So this together combines with Terraform, where once you provision infrastructure, we do Ansible, we run Ansible scripts on provision infrastructure and set up the set up entire prerequisites that is required for your application before deploying. Post that, we can use Ansible again to deploy your application as well. So I'm going to show you the entire pipeline of that in the course period. So we have Chef and Puppet as a competitors for Ansible. Okay, this is where the entire picture changes. Where this is about observability stack, OBS stack or monitoring stack we call it as, and then we are gonna monitor a lot of things here, where we gonna monitor the infrastructure, we gonna monitor network, we gonna monitor application services of multiple services, where we fetch the logs from the application and put it on Prometheus, and Grafana is the one that pulls the data from the Prometheus and show it on a visualization format in the graphs, or in the maps, like however we want. We can fine tune however we want to visualize our entire flows. That is where we think of Prometheus and Grafana. Coming to individual topics, Prometheus is again a flexible tool where you can store, where it collects the data from the applications and store it, and is going to take the metrics, all the related information data, collects the information data from the infrastructure and applications and store it. Grafana pulls that and show you the visible visualization process. We have Zabbix, Victoria Metrics, and we have other tools to monitor. Prometheus and Grafana is two tools when you talk about the Kubernetes cluster, or when you talk about the containerized projects. You can think of to implement Prometheus and Grafana. We want to show you the installation process on setting up the Prometheus and Grafana, and show the visual things of how this is getting worked. So in this slide we are going to talk about log monitoring. So we monitor the logs of the applications here. So we use ELK stack, Elasticsearch, Logstash, and Kibana. So Logstash is again a data processing tool where it collects the data from the application, transforms it, and makes it in a simpler way makes it in a simpler way, and sends it to the Elasticsearch as an input. So Elasticsearch will collect the data from the Logstash, and Elasticsearch is a search engine where it stores and indexes the data in JSON format, and it will be available for any of these third-party tools, or any tools that visualizes the data, logs data um, uh, in a graphical mode. So here we are using Kibana to visualize our logs. So the input for Kibana is Elasticsearch. It takes the input from the Elasticsearch and visualizes uh, all the analytics, the time frame. Based on the time frame, we can see the logs, how many logs we got. We can collect the errors, we can see the error codes, messages, all this stuff we can visualize in the Kibana. That is where ELK stack comes into picture. We have Splunk and Datadog for monitoring the applications. So this is where our entire concentration will be. Post our setting ups, installations, configuration process, the demos that we give, all these things ends up here, where we implement all those previous information, or the uh, data, or anything that we covered previously. We wanna put it on the live environment and show you exactly how the entire process works in, which is very close to the real time, where we cannot replicate the entire real time, because those real time projects involves enterprise editions of the tools, where people uses cloud-based Jenkins, which is again enterprise version of Jenkins. We're gonna use a very free open source versions. So we're gonna take very close to the real-time projects, but then we're gonna tell you how exactly the process works in real time. So these projects, once these projects are done, and if you can understand these projects, these where uh, you become master of DevOps. So when you try to implement these pipelines in your architecture and try to practice it, your half of the work is done. So that is where we're gonna cover multiple projects here. So it starts with CI/CD integration of tools like GitHub, Maven, SonarQube, Jenkins, Nexus, Docker. We're gonna show you the installation process, integration process, and create a build, and then publish the artifact to the Nexus. We're gonna create an image of the application image and publish it to the Docker. We're gonna show you how it can be done in the real time. So second project will be we're gonna create the build and release pipeline for Java based projects. We're gonna publish our artifact into the Nexus, and then publish our Docker image to the Docker Hub or AWS ECR by using Jenkins file, which is written in Groovy. We use workflow libs and shared libraries to achieve this. So the third project will be we want to create an infrastructure pipeline using Jenkins and Terraform to provision multiple environments on AWS. So we're going to create a reusable model of Terraform scripts, and then we're going to give it as a feed to Jenkins, and then create a script to run this Terraform code, and it is going to provision infrastructure based on the inputs that you have provided. So we're going to show you the entire pipeline of how this can be done. In the fourth project, we gonna cover the configuration and deployment of applications on EC2, where so once we create the infrastructure in previous pipeline, on once that is provisioned, we're gonna trigger this pipeline where it is going to take the artifact from the Nexus and then deploys it on EC2 by using Ansible. That is what we are going to cover here, and this is again a separate pipeline. So last one will be concentrating more on Kubernetes, where we are going to deploy applications on Kubernetes. It could be managed Kubernetes or AWS EKS based on the scenarios. We're going to show you the deployment process by using Argo CD. Argo CD is a continuous deployment tool which is very effective for deploying the containerized applications on Kubernetes or Rancher or any Kubernetes orchestration tools. So that is what we are going to cover in the real-time projects. Also coming to the slide, course completion stage, what we are going to offer once a candidate drills into these DevOps concepts and got the practical knowledge and theoretical process uh, process knowledge. Once we get here, what we are going to offer, we're going to give you resume building. So we write each and every sentence, and then we're gonna see what we have done in the previous sessions, and we're gonna write based on that. We should not copy anything from the open source resumes. We're gonna write everything by ourselves. That is first point, resume building. We will build the clear cut resume which is going to cover all the topics that we have discussed. And tool-wise interview question and answers. This is going to cover when we are discussing each topic or a tool. I'm gonna tell you what kind of topic is expected, and we are going to cover only the topics that are required in the process, not the things that is needed outside of the tool. There are a lot of things that we can discuss for each tool, but which is not required, and it is time consuming for any people to understand, and without implementation there is no need of learning it. So we're gonna teach what we are going to implement and what is required for you at interview point or the regular day-to-day activities. That is what we're gonna cover for each tool, and we're gonna discuss the question and answers related to that particular topics. So interview assistance, we are gonna help you to market your resume and see if there is any openings and guide you on that process, or try to refer you if there is any of the people, any of the members of my network is available. I'll help you to refer there, or if you have any issues with the interview part, we're gonna help you with that on that front. That is what interview assistant mean. And the last line, which is talking about real-time process discussion and mock interviews. Real-time process discussion in the sense, like we will, once your resume is ready, we will talk about how to introduce yourself, and you can we have to talk about the day-to-day activities that we are doing. And then third part, we are gonna give you the branching strategies, CI/CD pipeline, and deployment process. So this is what the real-time discussion, and these things that we are going to discuss, that is covered in previous sessions, when everything that we are doing practically at the time, we are going to list out all these questions and give the answers based on that. So that is what real-time process discussion means, and that is very close to the real-time projects in the organizations. So out of our experience and industry standards, we have designed these discussions out of it. On mock interviews, once your resume is marketed and you are about to get any schedules done, that time we are going to take the mock interviews from the industry experts, and we're going to help you where you are lacking and how to improve in that area. So we're going to talk more on those things once the course is done. That is what we are going to offer you in the post course completion stage. And then if you are joining late, or if you are missing any sessions out of it, you can reach us on we have different different contacts, and then the content that is available in the internet. And once you register your course, you can always revisit back to the sessions. So we'll be providing all the recording sessions, the commands, and the blogs that you need, the screenshots that helps you to do it in practical way. All the things will be available at one stop. We have our own Android app called DrillDevOps in Google Play Store. You can always visit that and try to attend those classes from the mobile itself, and try to have a recording sessions, and you can always revisit the recording sessions and try to get all the commands that is listed in our blog spots or the PDF that we are going to share. And that is where one stop you can see all the content inside it. So that is where we are offering our course, and we have our own website as well, which is shown in the next slide. Should you have any questions, please reach us on DevOps, DrillDevOps@gmail.com. We have our own website, www.DrillDevOps.com. We have our own Android app in Google Play Store. You can download it and try to register yourself for paid course, and browse the content inside it. And we are going to do live sessions, and then if you are missing any live sessions, you'll be always having recording session with all the commands and the interview topics, and with answers. We are going to provide everything based on the tools and the topics that we are going to discuss, and we're going to share all the contents or the updates that we are doing through the app DrillDevOps. And then we are going to host few of these demo sessions in YouTube, which is DrillDevOps channel. You can access DrillDevOps channel and try to see what is happening with the channels. You can always reach us Instagram. We have a DrillDevOps account. You can like and you can like and follow. Based on that, you're going to get updates. You can subscribe to YouTube. You can see the latest content and the batches, all the information about the course that we are going to cover. We'll be airing out in the YouTube, Instagram, Facebook, and the Android apps. We're going to market there, and you can see the content that we are going to cover, and then the live sessions in the DrillDevOps app. So we have our own DrillDevOps Facebook page. You can always access it. Try to follow it to get the latest updates about the batches the course content that we are going to cover and what we are going to offer post our completion of the course, and the real-time projects that we are going to deal in the entire course period. So the duration of the course will be anything around 60 to 80 days. In between, we try to cover all these things. We cannot completely tell the duration of the time, but we are going to target between 60 to 80 days based on the audience understanding and the real time examples that we are dealing with. So that is where we're gonna have that duration. And happy learning. Welcome to Drill DevOps. Thank you all for attending this session patiently. We hope you join our course and see what is happening, and we're gonna help you with the understanding of DevOps and make DevOps easy to you. That is where we are targeting. Hope I see you soon in the live sessions. Thank you all.